All right. Let's get this right in view. Let's go ahead and zoom out a little bit on this bad boy. All right, we're going to do, this is lesson 2.1, and our goal as written on the board is we want to be able to determine if given values are a solution, and we want to be able to solve systems of equations. And we've touched on this a couple of times before, but it's still relevant. It's still something we need to be doing, and now we're going to be doing it with a lot more gusto than we had in the past. So I'm going to start, and I want what you guys to do in your notes is along with me. I want you guys to start by making a coordinate grid, just like this. I don't know why I made it so negative here, but I did. Y and X. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So what I will do for you guys for questions like this is I'm going to give you a system of equations, a system. And as we remember, a system merely means two or more equations. Two or more equations. So a system simply means multiple equations. So I might say something like this. I might say y equals 3x minus 2. That is one equation in our system. And then our second equation might be something like y equals x. Okay? Y equals 3x minus 2, y equals x. And so my question for you will look something like this. I will say, find if the given point is a solution for the system. And so what that means is like the given point is a solution for the system means does it solve it? So I might give you a point like 0, negative 2. Okay? We'll call this point A. And what we're going to do is we're going to figure out if point A is actually a solution for the system given. But to be able to do that, I have to graph my system first. So I'm going to start with my y. I see that I have an intercept of negative 2 and a slope of 3. So I go up 1, 2, 3 over 1 like this. Okay, so that's going to be my line. Connect it. It's going to look something like this. Again, I'm freehanding it, so it may not be the single most accurate thing ever, but it'll be in the right ballpark. Then I'm going to do my second equation, y equals x. That tells me that 0, 0 is a point. My slope in this case is 1. I go up 1 over 1. We can actually even kind of see what the solution is since it just touched on it. I'll go ahead and draw that out. So now I'm asking about the point A. Point A. Point A is 0, negative 2. So 0 is here and I go down negative 2. So this point right here is A. 0, negative 2. And so the question is this point a solution to the system? What do you guys think? Thumbs up, you think it is a solution to the system. Thumbs down, you think it is not a solution to the system. What do you guys think? Give me some thumbs. Okay, I'm not seeing everybody participate, so I need to see what you guys think. Is this going to be a solution or is it not going to be a solution? Thumbs down. Absolutely, I see a lot of thumbs down, and that's because you guys are right. It is not a solution. It only satisfies one line, right? We can safely say that point A is on our green line, but not on our orange line. Thus, it doesn't satisfy it. You know, the not being on the orange line makes it so that it's not a solution for the system. So simply being a solution for one line is not enough for it to be the system. It has to be true for both lines. And looking at our graph here, what is the solution? What is the solution for our system? Right? We have to look to see where they cross. And we see that it crosses right here at 1, 1. Now, do these lines cross anywhere else? Well, how could they? Our green line is going to go on forever and ever this way, and forever and ever this way, while our orange line is going to go on forever and ever this way, and forever and ever that way. As they move forward positively, they're going to get further and further apart, right? And simultaneously, as they move together or move forever negatively, they're going to get further and further apart as well. So there is one and only one point where the lines intersect, and that's going to be at the point 1, 1. All right, there's no other solution for the entire system. While the green line has an infinite number of solutions and the orange line has an infinite number of solutions, the green and orange line together, the system only has one solution because there's only one point where they are going to cross. All right, so pretty much that's what's going to be asked of you guys for the homework. You're going to be asked to graph these systems. You're going to be asked to check points by plugging them in. And actually, let's go ahead and do that. We're going to do it a different way. We did it on the graph. We saw that A was only on the green. But I want to show you guys a different way of doing this. Okay? Let's imagine instead, I'm just going to pull out another picture, or another paper here. Let's check our work. So I have y equals 3x minus 2. And I'm trying to see if the point A, which is 0, negative 2, is a solution. So to do that, all I have to do is plug in my values. In this case, my y is negative 2. So instead of y, I'm going to write negative 2. And that's going to equal 3 times my x, which in this case is 0, and then subtract 2. All right? So I'm just going to go ahead and do this. Negative 2 equals, well, 3 times 0 is 0, because anything times 0 is 0. 0 minus 2 is negative 2, so negative 2 equals negative 2. Because these are equal, this tells me that A is on our green line, right? Because it works out, I know that A is on our green line. But what I'm going to do now is I'm going to do it for our orange line. And our orange line was simply y equals x. And so I'm going to do the exact same thing. Y is negative 2, x is 0. Now, does negative 2 equal 0? Absolutely not. We know that it does. That's not true. And so we can say that this point is not on the orange line. It does not satisfy it. It makes it untrue. Okay? Right? If it's true, it's on the line. If false, it's not on the line. Right? And sure enough, when we look at our image, we see that it is on the green line. It is on the green line. It is not on the orange line. Not on the orange line. So that's all I'm asking you guys to do today. I'm asking you to be able to graph two lines, find where they cross, and I'm going to ask you to take a point, plug it into different equations, and see if it makes it true. And from that, we will be able to complete our goal. We'll be able to determine if the values are a solution, and we can solve that system of equations.